In this video, we're going to be going over how to add a treatment plan, how to add beams, reference points, and how to calculate your first plan. So the first thing we're going to do is you always want to make sure you review your contours before you start planning, especially if this is the first time you're looking at the physician's contours. So your GTV, CTV, PTV, you want to make sure those look okay and make sense to you. If they do, we can go ahead and start planning. So the first thing we're going to do is come up here and go to Insert, New Plan. We're going to create a new course if we need to. In this case, we already have a course created, so I'm just going to use C1 as my course. For now, I'm going to leave my plan ID as Plan 1. And here, you need to select your PTV or your target. In this case, our target is this PTV right here. So we're going to make sure we select that. And what it's going to do is create a reference point, a primary reference point for our plan. And it's going to use that plan target volume that we selected in the previous step right here to create this point for us. So if we click, so you have to create a point right here in order to insert your plan. Every plan needs a point. So we're going to insert a new reference point by clicking this button. And notice, again, it chooses that patient volume that we selected previously, which is good. That's what we want. It just copies the name. So whatever your volume is named is what it's going to populate as the ID up here. And we're going to leave it like that. I usually just leave this ID alone, but feel free to change it if you want to. Click OK. Next, here we're going to select our treatment machine. So I'm going to select TrueBeam. Here's where you can verify that the orientation of your CT sim is correct. So in this case, we do have a head first supine scan. It should automatically select the correct position, but it's always good to double check. And it automatically wants to add a beam for you. So again, I'm going to leave the ID as is for now. We already selected TrueBeam 6x, so I'm going to leave for now. But this is where you would change the energy, which we'll go over here in a little bit. I'm going to click OK. All right. So a few things to note here. First of all, what it does is it places this beam. It places the isocenter of the beam, so where the beam is pointing, right in the center of your target. So in this case, the PTV. And remember, the isocenter is just the isocenter of the gantry, of the linear accelerator. So the beam is going to rotate around that isocenter, okay? That's all the isocenter is. And the isocenter is attached to your isocenter group right here. So if we insert a new field, that field is going to also just be attached to that isocenter group 1, okay? And you can move that isocenter in a few different ways. You can drag, you just click on it. This red circle is your isocenter, you click and drag. You can click and drag in all 3 planes. Or what I like to do is I like to kind of find where I want my isocenter with my viewing plane intersection. So these dotted lines here represent what view we're looking at here. And I like to just scroll around and find right where I want my isocenter with that viewing plane intersection. And then if you right click on isocenter group 1, you can align your fields to your viewing plane intersection. Sometimes I just find that easier than trying to drag this around in all 3 views. You can also align to a structure. So in this case, we just want our ISO basically to be in the center of our PTV, which is what it did in the beginning anyways. But if we can redo that by coming here and telling it we want to align our isocenter to our PTV, and it'll just jump right back to the center again. Okay, so that's your isocenter. Don't confuse your Isocenter, which is not an actual reference point. If you notice, your Isocenter is down here and it's just attached to your fields, okay? Our reference point that we created when we made the plan is up here, is PTV_P. And if we come over here to our dose tab, this is the target volume that we selected when we made our plan. And if you click it, you can change that if you want to or need to. Here is the reference point that we made, the primary reference point that we made, okay? And again, you can click and change that here if you need to. So, reference points. The reference point that you create when you make a plan is called a virtual point, okay? It has no physical location in this plan. We cannot see that point anywhere on this CT or in this plan. It's called a virtual point, and we use virtual points as our primary reference point, okay? And all the virtual reference point is doing is tracking dose, which will make more sense here in a little bit, but we're gonna use it to track dose, okay? And let me delete this field that I added, and we'll focus on this first field. So for this first plan, this easy spine plan, this simple spine plan, we're gonna do an APPA plan. Okay, so this is gonna be our AP field. If you want, you can come in here and relabel this AP. We're gonna leave our energy as 6x right now and our dose rate at 600. Okay, so the first thing we need to do or want to do is shape this field around our PTV, okay? So if you look over here, this is kind of a 3D view of what we're looking at. And you can zoom in with your zoom in tool right here. You can also, if you have this view selected, you can use your control key and your roller on your mouse, your little wheel on your mouse, to zoom in and out. Same thing in any of these planes. Control key, use the wheel to zoom in and out. Or you can use this magnifier, click and drag to zoom in too. Okay. But anyways, this 3D view, it's just going to show you your beam. It's going to show you anything you have checked over here. So right now we have our beam checked and a few structures checked. So that's what's going to show up over here. If you right click, you can set beam's eye view to our AP beam. So we relabeled it AP, right? That's why it says AP here. So set beam's eye view to AP. This is our beam's eye view of this field. So you don't have to add a DRR, but it's always a good idea to add a DRR. So we'll do that. So I'm going to right click, new DRR. Okay, and you have a few different options here. So I suggest playing with all these options. Usually though, this abdomen at the top looks pretty good. So if you click one, hit apply, it adds a DRR here. If you look at this DRR and decide, you know, it's too dark, it doesn't show quite what we want, you can try another one. Ooh, that's even darker. Maybe too light. You get the idea. You can kind of walk through these and choose one that seems appropriate for the situation. Okay, so now we want to shape our field to our target. So you can do that a few different ways. Let's blow up this window. I'm going to click this button in the corner here to blow it up. Now you see all these red squares. You can use those to drag your jaws around. So these yellow lines here are the jaws of the LINAC, okay, and we can move those jaws with those red squares. So I'm going to uncheck the zoom. So you can see I still have my magnifier open. I'm going to uncheck that, which then will let me drag these around. Okay, so you can do this manually like I'm doing right now. Okay, drag those around. Next, we want to add an MLC to our field. So if we right click on our field, we're going to click new MLC. You can see all the MLCs inside the head of the gantry show up, right? And we want to use those to further shape our beam. So again, you can do it manually. I'm going to click this button up here, this shaping tool, okay? And you can just draw what you want your field to look like. So we can just draw a shape that kind of conforms to the shape of our PTV here. And then the MLCs will just bounce right to it. If you draw the field and most of it looks good, but you just want to change, this side or even just this upper part of this side over here, what you do is you use this Select MLC Leaves tool right here. And you can use your Control key to select individual leaves. See that? I just selected 3 leaves. Or you can use your Shift key to select a range of leaves. You can click and drag those leaves around manually, or again, you can use this shaping tool to move them and shape them. And when you use this tool now, it's only going to move the ones you have selected. So only these green leaves will move. So even if I draw way up here, it's only going to shape these green ones. And what you want to do in order to make those move is those leaves will bounce to the nearest red line, okay? So I don't want to go close up this way. I want to come behind because I want these leaves to bounce right to this red line that I made. So I'm going to close behind, and as soon as I close this loop, those MLCs, bounce to that line we just made. Okay, just like that. So that's kind of how you do this manually. And then of course you can, start adjusting other leaves or pick a different range. Or you can just completely start over to change the entire block. Okay, so those are some manual tools to shape MLCs with. But you also have this fit to structure tool, and this is what we're going to use most of the time when you're doing 3D plans. Okay, so I'm going to fit to structure, and you choose your target up here. Again, it auto selects our PTV because that's what we've told it is the target of this plan. And I just want an even half cm margin around our PTV all the way around. So I'm going to put 0.5 in here and click fit. And you can see it shapes our beam for us with a half cm margin. After you do that, if you don't like what it looks like in places, maybe you don't want it to cut so close in these corners or something like that, you can still manually adjust afterwards if you need to. Okay, so we have our AP beam. Now we need our PA beam. So to do that, I'm going to right click on this beam and I'm going to click New Opposing Field. You can see what that does. It creates an opposing field. So we now have, we had a beam at 0 degrees. The opposing field would be at 180 degrees, okay? So this is our PA field. PA field at 180. But something important to note is this is a half cm margin, right? Well, this MLC shape right here, it is not a perfect half cm margin. It just copied the exact same MLC shape as the AP field. And depending on the shape of the PTV and how the divergence works out, it won't be a perfect half cm margin. So you always need to redo your MLC on additional fields that you create, even if you just oppose those fields, okay? So we're just gonna really quickly do the same thing for this PA field. We're gonna auto fit a half cm margin to our PTV. And as soon as I click fit up here, you can watch these MLCs, they will all move slightly, okay? There we go. Just very slightly, because we did put our isocenter in the center of the PTV, so that divergence is not a super big issue, but you always need to do it because, as you saw here, they still did move slightly, okay? So we have our APPA beams. Next, we need to add our prescription. So you come over here to the dose tab. This is where you add your prescription, okay? So we're going to just do 300 times 10 for this plan. We have our beams, we have our prescription. Right now we are ready to calculate. So let's go ahead and calculate. Okay, so if you didn't notice, this is the calculate volume button. This button will calculate only one plane, so one slice. You never really need to use this button. It's always going to be this calculate volume button. Okay, if you want to uncalculate a plan for any reason, you can use this button right here. So reset calculation volume, it'll uncalculate your plan. Okay, a couple things to note. So this plan right here, so 100% of our dose, which is what we want to cover our PTV with, our target with, is this red line. You can see it covers our whole field, but look at our hotspot. So if you look over here, our 3D dose max is 261%. It's a very hot plan. So why does our plan look like this? So first off, you can see our plan normalization mode here. We have no plan normalization. Our plan normalization value is 100%. We have two fields though, and if you look over here, when you add two fields, each field weight is 1. Okay, so if you click on the F3 button, it'll open up the weight for your fields. Or if you come up here to planning, field weight is right here, and you can see the shortcut is also listed there, F3. Okay, if we take all the weight away from our PA field and add it all to AP and click apply, well, let's start over. Let's put it back to 50-50. So the reason our dose is so high, 261%, is because our plan is scaled based on a factor of 2. We want it to be scaled on a factor of 1. So every 3D plan you do, you're going to want to click F3, and the first thing you want to do is change this total field weight to 1 so that everything's based on a factor of 1. Okay, see now our max dose drops down to 130, and everything is scaled based on a factor of 1. It's much easier to think about that way. So you're going to want to change that to 1. Now let's see if we take all of that PA weight away and click apply. So our plan normalization mode here is how we tell Eclipse, how many monitor units to deliver from each field, basically. Okay, so right now we're delivering all our monitor units from field 1. And since we have no plan normalization value, what it's doing is it's using the Isocenter to determine those number of MUs. So right now it is delivering, you can see this red line, our 100, is going right through our Isocenter, okay? So it's delivering as many MU that it needs to in order to make that happen. So in order to get 100% of our dose into our Isocenter, all from our AP beam, it needs 424 MU, okay? If we do the opposite, make all of our dose come from the PA field, see the opposite happens. Now all of our dose is coming from the back, but it's doing the same thing. It's just trying to get 100% to go straight through our Isocenter, and it takes 314 MU to do that. Okay. At 50-50, which is what the plan started at, now it's just trying to get 50% of our dose to come from the AP field to our Isocenter, 50% from PA. You can see our line gets a little squiggly because now we have contribution coming from both sides. But again, it's basically it's showing you the minimum monitor units from each field to get that 100% line to go straight through our Isocenter. Since it's 50-50, basically 150 centigrade is being contributed from the AP field, 150 from the PA field. Okay, so that's what's happening. It's doing a little bit more complicated calculation. If you don't always have to have the Isocenter in the center of your field, sometimes that Isocenter will be blocked even by MLCs and JAWs, and then it's doing some other calculation. But long story short, even if you have no plan normalization here, Eclipse has a way to get you a starting point, a starting number of monitor units, okay, to get a plan. But what you're going to want to do is adjust this weight. So we have a lot more tissue to travel through from this AP side, right, than the PA. That's why if you look at here, we have 105 and 107 showing. So there's this big hot spot. So on this plane, you can see 128% here. So there's this massive hot spot up here, but there's not one down here. And that's because this distance is so much shorter than this distance. In order to get 50% to our Isocenter, it has to pump a lot more MU from this AP field than it does from the PA field, okay? That's why our monitor units are so much higher from that AP side, just because of distance. So you will rarely leave your percentage exactly at 50-50. What you're going to want to do is kind of adjust that. So we want to lower that hotspot from the AP side. So we'll tell more dose to come from the PA beam and less from the AP. And you can see that hotspot starts to even out, right? So that's what you'll do, is adjust your weight. Let's put it back to 50-50 real quick. Actually, let's put it back to 100. Just one more time to clarify. So right now you can see our total field weight is 1. So our 100% line is going right through that Isocenter when we only have dose coming from one field. Just to drive, this whole field weight point home, when it was at 2 initially, the reason why it's so hot is because it's putting 200% of our dose now through that Isocenter. Okay, so if we change this to 200%, so this pink line is now 200% overdose, and that 200% line is going right through our Isocenter. So that's why initially, if you calculate your plan, you leave your field weight at 2, or if you had 3 beams, it would be 3 and 300%, 4, 400%, so on. And you leave this at no plan normalization. That's why your plan is going to be so hot, and that's why you should change this to 1. Okay. Okay, we'll leave this at 50-50 for now. Let's change this back to, let's change it to 110. Okay, so what are some of your other options here for normalization? And again, the plan normalization is just how are we telling Eclipse to deliver monitor units from our beams. That's all the plan normalization is doing. And if you click here, we have a lot of different options, okay? So let's just start at the top. If I click 100% at target maximum, click OK. Now what it's doing is, if we look over here at dose statistics, turn our PTV on, the max dose of our PTV is 100%. So now what it's doing is giving however many monitor units it needs to deliver from both beams to put the maximum dose on our PTV at 100, okay? It didn't change our field weight, so if I click F3 again, our field weight is still 50-50. It didn't actually change anything about our plan other than the monitor units. All it did is scale those monitor units in order to normalize the plan so that the max dose on our PTV is 100%. Okay, so that's what I want to make sure everyone understands, is that this plan normalization mode, all it's doing is scaling monitor units. Okay, it's not affecting the plan in any other way. It's just scaling your monitor units. So if we try another one, 100% target mean, You can see the isodose distribution does change, but again, it only changes because it's scaling these monitoring units up or down. It's just making your plan hotter or colder evenly, okay? It's just scaling that. Again, field weight 50-50, field shape, everything stays the same. It's just scaling those MU to meet this this objective right here. So if we look at dose statistics again, the mean dose is now 100 because we're telling it to be 100. Okay, it's just scaling the plan to do that. All right, so you can see we have a bunch of different options. I just want to go over a couple more. So a very popular option that we'll use a lot in these videos is, coverage or normalization based on coverage. So a lot of times you get a minimum amount of coverage, from the physician. Kind of gold standard is we want 100% covering 95% of our volume. We'll use that a lot, but you can set it however you want. So if you click OK, now it's normalized so that 100% of our dose is covering 95% of our PTV volume. All right. So just to recap and go over what this means, right now we're at no plan normalization, which is how your plan starts, okay? No plan normalization. Field weight is at 1. This plan normalization value is 100%. So that means it's just, we're not scaling at all, right? It's following those original rules. So it's trying to get, so your Isocenter, let's see here. So your Isocenter is this red dot, but just to clarify, you see how you can still see that even if you scroll up and down? Don't let that confuse you. So you can see it changes from orange to a more solid red. So right where it changes to solid red is where your Isocenter's at, okay? And then it'll stay solid red superior to your Isocenter. And it'll stay orange inferior to your Isocenter, okay? So that can kind of get confusing sometimes, but to really, make sure you're at your Isocenter location, you need to kind of look at all 3 planes, or if you right click here, you can move viewing planes to Isocenter or entry point. But again, I just wanted to drive home. So at no plan normalization and or plan normalization value of 100, it's just making sure 100% of our dose goes right through that Isocenter point, which is what it's doing right now. If I change my normalization somehow, so I'm going to tell 100% to cover 95. Again, all it's doing is scaling our MU to make that happen, right? And you can get an idea of how much it's having to scale from that initial starting point with this plan normalization value. All right. You can also, another popular way is, say you have your plan like this, but you just want it to warm up a little bit. You can just change this plan normalization value, okay? So to heat a plan up or to increase those MU, make our plan hotter, you normalize down, okay? So if I want this to get hotter, maybe I type in 94. You can see our max dose is 137. As soon as I type in 94, click apply, it goes up, right? If I go down some more, it keeps going up, okay? I'm heating my plan up. If I want to cool my plan down, I normalize up. All right. So another popular way is to just normalize based on coverage. Another popular way is to use this plan normalization value, and you can just look at your plan and evaluate if you're happy. If you look at this and you decide it's too hot, you can just change this number, go up, cool your plan down. You can even go above 100 too. You can see my plan just get colder and colder, okay? The last thing I want to talk about is you can normalize to a physical reference point as well, okay? So if I come over here to reference points, I right click, I can add a new reference point and location. Okay, let's just call this normalization, or no, let's just call it calc point. You have any point you create, you have to associate to a patient volume. So again, your primary reference point, you'll always associate to this target volume that you select here. Calc points or any additional points, always just assign to the body. Okay, click OK. And now you can immediately tell the difference between a virtual point and a physical point. The virtual point, you can see the shape here is, the picture is a little different. That point, that kind of bluish cross is inside a yellow square on a virtual point, and it's not in a physical point. But again, you can tell the difference right away too. The physical point is here. It is in the CT. You can click it, drag it, move it around. It's a physical point, okay? So what you can do is you can move that point to some place that you want to normalize to. And so a lot of times you would put it right on the edge of your PTV or something like that. So we put this point right on the edge of our PTV, and we can change our primary reference point. So the point of a virtual point is a virtual point will always track your exact prescription dose, which is usually what you want. Okay, so it's going to track 300 centigrade times 10 for a total of 3,000 centigrade. So when you transfer this plan to your EMR system or ARIA or Mosaic or whatever you're using, it'll track the correct dose per fraction and the correct total dose with a virtual point. What you can do though is you can change it to a physical point if you want, but you can see if you do that and you don't normalize to that point, our dose gets weird. So it just tells you exactly what dose this point is getting. So right now this point is only getting 295.7 centigrade per fraction. This is our total dose. You do not want to track something like that in your EMR. You want it to track exactly what you're showing in your prescription. So if you do use a physical point right here like this, you need to normalize to that point. So what you can do is you can normalize 100% at your primary reference point. Okay, now it'll track properly because I'm telling it to give exactly 100% to that point. And then you can move this point around in order to scale your dose. And again, you can see our plan, our isodose distribution is changing. It's not because the weight is changing. It's not because anything with the beam is changing. All that's changing is this monitor units. And right now, our field weight is still 50-50. So no matter where I move this point, it's giving 50% of the dose for my AP field, 50% for my PA field. And so however many MU it takes to make that happen, depending on where this point is what it's scaling to. And no matter where I move it, it's going to force my plan to scale to that point because I'm telling it to, okay? So what you do is you just, move this point until your dose distribution looked good, until your coverage looked good, okay? You can also leave this virtual point here and use this option. So we want to normalize 100% at that calc point reference point that we made. So right now we still have our virtual point here. We're using yet another normalization option over here. It's really the same thing. It's just will look different on paperwork, points are in different places. But lots of ways to normalize. Throughout all these videos, we'll go over, a bunch of them and stuff. But for most of our 3D plans, we will not be creating this physical point. We'll just leave our virtual point in here, and we're going to either use this or this, okay? And there's certain circumstances where I like to use this one or this one, so we'll go over that more in other videos. But for now, just put this at 100. And we're going to keep this plan very simple. This is an APPA plan. All we're going to do is change our field weight here a little bit, even out this dose. So usually you want your plans to be fairly symmetrical. Okay, so this looks fairly symmetrical. This red 100 line is about the same shape in both places. Our 105 volume, this yellow volume, is about the same shape. Since we are treating the spine, which is posterior, we would want to err towards it being hotter posteriorly than anteriorly. So I might, add just a little bit more weight. So there we go. It's a little bit hotter, here in the back. Something like that. So the 105 is, a larger volume in the back than the front. But you can see, we're cold. Our PTV is cold. Most of it is not covered by 100. So what you can do, or what we're going to do in this case, is I'm just going to change this number until it is covered. You can see most of it is now covered, but we're still cold a little bit on this superior part here and this inferior part here. So let's try 96. A little better. Let's try 97. Whoops, I mean 95. All right, so that's looking pretty good. The last step when you're planning is to check your DVH. So if I right click, I'm in this upper right window. This top option is show dose volume histogram. Okay, and this is where you're going to evaluate the dose to your OERs and your targets and everything. All right, so we already have this PTV turned on. If you want to look at dose to anything else, you would just check them and they would show up in your DVH, give you some metrics down here. But right now we're just going to look at our PTV. And we want, let's say we want 100% to cover 95%. So 100% is this 3000. If you click on this button right here, this crosshair button, you can click on this line to get a little bit more exact numbers. So if we click right on 100% right here, and you can see it's very hard to click right on exact numbers. So right now it's 3000.62 centigrade. You hold your shift key down and use your left and right arrows, it'll go based on whole numbers, so you can get right on 3000. At 3000 centigrade, we're only covering 89.3% of our volume. So you want that to be 95%. So let's keep normalizing down. Ooh, 94. Looks pretty close. So again, you can use your crosshair. Make sure you're right at 3000. 94.5%. So close. So now you can start, going at smaller increments. So maybe we try 93.8%. We are finally now above 95% coverage. Okay, so that's just an example of how to do it manually. You can also, and notice, so our plan normalization value is 93.8. 93.8. The much quicker, easier way is just to tell it to normalize 100%, covering 95% of our volume. 93.9 is what gets us exactly to that coverage. Okay, that is it for this video. In our next video, we'll be going over how to, do a little bit more complicated plan and how to add field in fields.